Bonjour, my name is Professor Philippe Girard, and this is my world history course. Over the next few weeks, we will cover the history of the world all the way from the origins of history to the year 1500. Believe me, it's going to be a fascinating ride. First, a word about the format. These lectures are intended for first-year college students, so if you're a 10-year-old history buff looking for cool stuff to watch on YouTube, some of the issues that we will discuss, including violence and sexuality, might not be suited for you. On the other hand, the lectures are meant to be a general introduction to world history, so if you're an adult expert hoping to learn more about a specific topic, like ancient Rome, for example, things might be a bit too general for your taste. I will only have one video on each topic, so there's only so much I can say in maybe 30 minutes. Think of it as a sampler menu. You'll get to taste a little bit of everything. So listen to all the lectures in order to get the big picture, and then if you discover that you absolutely love the Mongols or the Aztecs, just dive in and check out books from the library that are written by actual specialists to learn more about this particular topic. If you're watching those lectures because you're some random dude who stumbled upon my playlist on YouTube on a sleepless night around 3 a.m., well, just kick back and enjoy the show. Good night. But if you're a student who's actually taking my class for credit, there are some ground rules. First, take notes. We'll cover a lot of material in the course, so unless you're Rain Man, there is no way that you will remember everything. I distributed a PowerPoint in the course to help you take notes, so use that as a guide. Pay particular attention to the terms that are listed in the PowerPoint or that will appear on the screen because, wink, wink, they might be on the test. Here's another hint. If you have a hard time understanding what I say, either because of my sexy French accent or because I covered too much foreign material, well, turn on the closed captions. And finally, if you can't ever get enough world history, check out the homepage of my channel, youtube.com/pg245091. I have a follow-up course to this one, World History since 1500, and I also teach a modern US history course since 1877, and I also have a radio show on women's history. Now that we've got all that out of the way, let's start with today's topic, the introduction to the course. How much space and time does a world history course cover? And actually, when does history begin, even, anyway? Well, as far as space is concerned, world history covers, well, the entire world. Because this is world history, we will cover not just Western civilization, Europe, the US, but the entire world. America, Africa, the Middle East, Asia, all that. And that might seem like a lot, but in the grand scheme of things, our terrestrial world really isn't that big. Here's the Earth as seen by the astronauts who went to the moon. It has a circumference of 40,000 kilometers at the equator, which may seem big, but a beam of light, the fastest thing that we know of in physics, could go around our Earth in roughly 1/10 of a second. And remember that the Earth is not alone. There is another big body, our moon, which is 300,000 kilometers away, 200,000 miles, which is 1 whole second away from us, traveling at the speed of light. The moon is very noticeable in the skies, which is why a lot of civilization that we'll study in the class worship the moon as if it were a god. They also worshipped in many cultures the other big orb that is very noticeable in our sky, and that would be the sun. And the sun is way bigger than our puny planet. If you were to create a scale model where the sun would be the size of a giant ball, about a meter across, the Earth would be the size of a tiny marble by comparison. And the sun is also far. Even though light travels at some unfathomable speed, 200,000 miles per second, it takes 8 whole minutes for light to travel from the sun all the way to the Earth. So if you use a scale where the Earth is just a tiny marble and the sun is about a meter across, that marble would be a whole football field away from the sun if we were to keep things to scale. And that's just one element of a solar system that encompasses 8 planets plus Pluto. In other words, our solar system is big. Still using that same scale, where the Earth is a tiny marble, the sun is a 1 meter ball, there would be a football field away from us at the scale. Some of these outer dwarf planets like Pluto and Eris would be some 10 or 20 miles away from us at that scale. The farthest objects sent by humans are the probes Voyager 1 and Voyager 2, which are about the same age as I am. And these were launched in the 1970s and travel right now at over 30,000 miles per hour, roughly 50,000 kilometers per hour. And yet, even at that incredible speed, after 40 years and a journey of 14 billion miles, these probes have just recently left the solar system into interstellar space. So we're just one planet among 8, lost like a tiny marble in the immensity of the solar system, and there's more. Once you get to interstellar space, just like the Voyager probes have done, the nearest star to our sun, called Proxima Centauri, is way, way farther than that, over 4 light years away. 4 years. That's how long it takes for the light from that star to reach us, going at 200,000 miles per second. But the Sun and Proxima Centauri are just 2 stars among many. In our galaxy alone, the Milky Way, the one that you see across the sky on a beautiful dark summer night, there are around 300 billion stars would be. And they are spread over such a vast distance that it would take light 100,000 years to go from one end of our galaxy all the way to the other, again, at the speed of light. So that you know, the Milky Way is not the only galaxy in the universe. There is another one near us, Andromeda, that has 1 trillion stars with a T in it. And by near us, I mean that Andromeda is 2.5 million light years away. However amazingly large the Milky Way and Andromeda might seem to us, well, they're just specks in the universe. Thanks to the work of the astronomer Hubble 100 years ago and the more recent telescope named after him that was launched by NASA in the 1990s, we now know that our galaxy is far from the only one in the universe. In fact, there are probably another 100 billion galaxies in the universe, each of them home to billions and billions of stars. And as far as we know, most of those stars have planets of their own, many of them. In fact, the observable universe, which is, as far as you can see, with a big telescope like Hubble, that observable universe is so vast that it would take light about 100 billion years to get from one end of the universe all the way to the other. That same light that is so fast that it only takes 1/10 of a second to circle the Earth would take 100 billion years to go across the universe. And then there is whatever exists beyond the observable universe, which is huge for sure, but we'll never know what it is because the light from those far away confines is too far away to ever reach us within our lifetime. So next time you think that a class studying the history of the entire world is too much, and I'm just being mean, well, remember this. Our Earth is just one of 8 planets around the Sun, which is just one of 300 billion stars in the Milky Way, which is just one of 100 billion galaxies in the known universe, which may be just one small part of a giant multiverse. Mind officially blown. So, now that we know how much space world history covers, let's think about how much time it covers. Maybe pause the video for a second and ask yourself, how far back does history go? You've all heard the expression prehistoric times, so clearly there's history and something before that, prehistory. But what is the dividing line? And the answer is, drum roll please, the invention of writing. And this might seem arbitrary. Why not use the invention of fire instead, or maybe the wheel? Both of these were huge steps forward for humankind, but there's a logic behind it. Historians rely on the written word to retrace the past. We read old diaries, carvings on old monuments, letters, laws, etc. Obviously, Homo sapiens, our species, lived before writing was invented, but we historians, we can't cover that period because we don't have the documents to do so. Prehistory, what came before, is something that paleontologists study, and they use their own techniques, like studying old bones and fire pits and whatever they do. But once writing is invented, that's when we historians step in. So when was writing invented then? Well, the answer is a long time ago, obviously, and that would be about 3000 BC, meaning 5,000 years ago from us. So in this course, which goes all the way to 1500 AD, we'll cover 4,500 years of history, from the invention of writing, 3000 BC, all the way to 1500 AD, which is a cutoff, and then I start the second half of the course, 1500 to the present. A quick digression about those terms, BC and AD, which I will use a lot in the class. BC simply means before Christ, so it's any date before the birth of Jesus, which we use as year 1 of our Christian calendar. AD, or Anno Domini in Latin, means year of our Lord, so it's any date after the birth of Jesus, after year 1. It's simple enough. In some books, you'll see BCE and then CE after dates instead of BC and AD. These acronyms stand for before the Common Era and then after the Common Era. The idea is to avoid referring to a specific religion like Christianity when studying history and to use a more neutral term. Personally, I'm all for the separation of church and state, but in this case, I find it a bit silly. When we speak about before and after the Common Era, the Common Era that we speak about, well, it begins with the birth of Jesus anyway, so there's nothing secular about it. We might as well use the terms BC and AD while we're at it. I'm not promoting any specific religion, I'm just using a tool, the Gregorian calendar, which happens to use the birth of Jesus as its starting point. That's all there is to it. If you want, you could use another calendar like Muslims, who start their calendar with the time when Muhammad fled from Mecca in 622 AD, for example. We'll study that in the class. My personal favorite is the Republican calendar of the French Revolution, because it begins in September 1792 with a French victory over a Prussian army. But there's already a ton of dates to remember in a world history course, so there's no point in confusing you, and I'll stick with a Christian calendar, the Gregorian one, in this course. Speaking of which, here is a little riddle for you. What happened between Thursday, October 4th of 1582, and then Friday, October 15th of 1582? In the Christian calendar, that is, not Muslim or revolutionary. Maybe you should pause the video for a second and think about it, because that one is a really hard riddle. So did you get it? No? The answer is simple. Nothing whatsoever. Nothing happened in those dates. Let me explain why. Up until 1582, Europeans used the Julian calendar, which is named after Julius Caesar. It's a calendar you're kind of familiar with. It has 12 months and 365 days, plus a leap year every 4 years. But the Earth does not circle the Sun in exactly 365 days and a quarter, so the Julian calendar is not exactly 100% accurate. Every year it would be off by just a few minutes, which doesn't sound like much, but after 1,000 years, it adds up. That's why in 1582, Pope Gregory XIII decided to change the way that leap years were calculated, but just a tiny bit, creating the calendar that we use today, the Gregorian calendar. To make up for all the small mistakes that had added up since the time of Julius Caesar, that calendar jumped ahead by 10 days, which is why people fell asleep on Thursday, October 4th, 1582, and then woke up on Friday, October 15th, and that's why nothing happened in between. Well, that was just trivia. All you need to know is that history covers a period since the invention of writing, 5,000 years ago, and 2, that we count the time after that using the Gregorian calendar that uses the birth of Jesus as year 1. That's simple enough. But back to the big picture overview, which is today's topic. A class covering the entire world since writing was invented 5,000 years ago, that may seem like a huge amount of material, and it is. But even that long span of time is not that great when you put it in perspective. Homo sapiens, which is to say us, our species of humans, we go much further back than that in time, about 200,000 years ago, long before writing appeared on the world stage. Maybe another digression, because I live in a very conservative area of the US, Louisiana, so I can already hear the groans from some of my students saying, wait a second, my pastor in Sunday church told me that according to the Bible, the whole world was created by God in 4000 BC. Well, according to the Bible, maybe, but there's no scientific evidence for that. The fossil record shows that human beings go back much, much further than that. And in this class, I will stick to what we can prove using science, historical research, with a reasonable degree of certainty. Okay, another digression before I get back to the topic. I've thrown around a lot of dates today, so you might ask yourself, how do historians or paleontologists know for sure that this event happened 1,000 years ago, or 5,000 years ago, or 10,000 years ago? Especially for events that happened before the invention of writing, when no one was there to record those events. Think about it for a second. Well, one method is dendrochronology, which is a fancy way to mention tree rings. And as you know, trees have rings inside their trunks, light and dark, alternately based on each year that passed and how much they grew in that year. And typically all the trees in the same region of the world will grow the same way based on how much water there was that year. So by cutting very old trees, you can have a record of seasons going back centuries for a given area of the world. And if you ever find a beam in an old abbey, you can compare that wood pattern to other trees that you have on file, and you can know that this beam was part of a tree that was felled, I don't know, during the drought, the year 1250, for example. A second method would be radiocarbon dating. Living things like humans or plants, we're made of a lot of carbon. It's organic chemistry. And the moment that these living things die, one type of carbon, the carbon-14 isotope, starts to decay at a predictable rate. So by measuring the amount of a plank of wood or anything dead, you can get a rough idea of when they died thousands of years ago. There's a third method. You can look at layers of soil. They're deposited on top of another, so digging is like going back in time. It's like a time machine. So if you find a layer of soil with artifacts from the 6th century BC, and then below you get to a layer dated to the 8th century BC, you can be pretty sure that any piece of pottery found in between those two layers, that would be from the 7th century BC. There are other techniques, but it's just my way of saying that we historians don't make this stuff up. We try to be as scientific as we can. Back to our species, Homo sapiens, which appeared about 200,000 years ago. We, Homo sapiens, are just one type of hominids, which is a general term for all the various species of human beings, as opposed to other primates like, say, I don't know, chimps or gorillas. Well, hominids go back far, even further than Homo sapiens, obviously. Paleontologists have found skeletons of early hominids that date back 3 or even 4 million years back in time. Most were found in modern-day Ethiopia and East Africa, like the skeleton that was nicknamed Lucy. From there, hominids migrated to Europe, Asia, and ultimately the Americas. So next time you hear some racist dude ranting about black people, remind him of that. His grandma was African too. At one point or another in our family tree, we were all African immigrants. Anyway, hominids have been on Earth in one form or another for over 4 million years, which may seem like an incredibly long time, but for biologists who study the evolution of life, that's just a blip. Dinosaurs, who ruled the Earth long before us, disappeared about 65 million years ago, and they were just one of many forms of complex, multicellular life over the past 500 million years. Simple life, like, I don't know, single-cell bacteria and such, that appeared even earlier, 3.5 billion years ago with a B. And by that point, the Earth was already 1 billion years old. So geologists, they use timescales in the billions of years with a B, much longer than paleontologists who study early hominids over millions of years, and much longer than a historian like myself who only speaks of centuries or thousands of years. But astrophysicists, the ones who study the origin of the universe, like stars and such, they have us all beat. Their timescale is over 10 billion years. According to the dominant theory on the origin of the universe, everything that we know, planets, stars, galaxies, everything, that emerged from a kind of explosion, the Big Bang, almost 14 billion years ago. To put everything back in order from the beginning to the end, the universe began with a Big Bang, roughly 14 billion years ago. Our sun and our Earth emerged about 4.5 billion years ago. Simple life emerged around 3.5 billion years ago. Complex life emerged about 500 million years ago, and that would include the dinosaurs, most of which disappeared 65 million years ago. The early hominids appeared around 3 or 4 million years ago, and among them, our species, Homo sapiens, would appear around 200,000 years ago. And history begins when we, Homo sapiens, learn how to read and write, and that's just 5,000 years ago. When you frame it like that, the class doesn't seem that daunting, no? Well, let's just express the same idea in another way, which I find even more baffling. Let's say the whole history of the universe was condensed into just 1 year. We would say January 1st, that's the Big Bang, and the end of December 31st of that year would be today. So if you use that time scale, the Earth would appear in September of that year. complex life would appear in November of that year. Dinosaurs would go extinct on December 31st of that year, or 30th. Homo erectus would appear at 10:48 p.m. on December 31st, and world history would begin just 15 seconds before midnight, if you kept it everything to scale. Anyway, let's sum up now what we learned today. This class will be about a tiny sliver of time at the tail end of the immensely long history of the universe. And by the way, we'll just cover one planet among billions of planets. So however daunting the class might be, everything since the invention of writing, don't get discouraged. We're just scratching the surface. Anyway, that's it for this general introduction. Next time we will start the class in earnest, starting with, you guessed it, the invention of writing. Goodbye and au revoir.